In this video, we're going to do a couple of warm-up solving equations problems. And you'll see these require several steps, maybe a little bit more than the ones we've done in the previous video. And then we'll do a word problem that applies our equation solving capabilities. So here we have 7 times w plus 20 minus w is equal to 5. So let's see if we can solve this. And like all things, there's multiple ways to solve these. I'll just solve it the way that seems most natural to me. So one thing I like to do is I like to distribute the numbers out. Because if I distribute the numbers out, I'll get a 7w, and then I can subtract w from there. So maybe I can merge the w terms somehow. So this 7w plus 20 I can rewrite as 7w plus 7 times 20. Remember, distributive property. So plus 140. And then we have this minus w is equal to 5. I just rewrote this part right here. I just distributed the 7. And now, just like I talked about, we can merge. We can take 7w, and from that we can subtract a w. So if you take those two terms, you get 6w. If I have 7 of something and I take away 1 of that something, I have 6 of that something. So I have 6w plus 140 is equal to 5. Now I want to get rid of this 140, because then I'll have 6w's equaling to something, and I'll be able to divide by 6 and all of that. So to get rid of 140, I can subtract 140 from both sides of the equation. And I'll do it in pink. Minus 140, not a minus 6w. So I'm just subtracting 140 from both sides of this equation. If something equals something, something minus 140 is going to equal something minus 140. We have whatever you do to one side, you got to do to the other side. So the whole point here was for these two to cancel out. You're left with the left side with just 6w is equal to 5 minus 140. Well, that's negative 135. And now we can divide both sides of this equation by 6, which is equivalent to multiplying by 1/6. And you get w is equal to, negative 135 over 6. Let's see, is there any place to simplify this anymore? Let's see, this isn't divisible by 2, and it also doesn't look divisible by 3. So this looks like we are done with the problem. And you can verify. Actually, let's verify, because this is kind of a strange looking. Let's verify that this is the answer. So 7 times, negative 135 over 6. That's our solution for w. Plus 20. Instead of 20, I'm going to write plus 120 over 6. 20 is the same thing as 120 over 6, right? Minus w, minus w. So w is negative 135 over 6. So subtracting a negative becomes adding a positive, right? So let's see what happens. This becomes 7 times, negative 135 plus 120 is negative 15 over 6 plus 135 over 6. Let's see what we get here. So then we get 7 times 15. So let me go over here. What is 7 times 15? It's 70 plus 35. So it's negative 105. This right here is negative 105. Negative 105 over 6. That is that right there. Plus 135 over 6. Plus 135 over 6. What does that become? This becomes 30 over 6, which is equal to 5, which is exactly what it needed to equal to. It is equal to 5, so we got the right answer. My spider sense was wrong. We did it correctly, even though we got this strange looking answer. Now let's do this problem. So once again, I like to distribute out the 9. Actually, we don't have to distribute it out. There's multiple ways to do this. Maybe we'll do it both ways. So the first way I like to do is distribute out the 9, so I don't have to deal with fractions. So you get 9x minus 18, just distributed the 9, is equal to 3x plus 3. Now we want to get the x terms together somehow. Let's get them together on the left-hand side. So let's get rid of this 3x on the right-hand side. And the best way to get rid of it is to subtract 3x from the right-hand side. But if we do it from the right-hand side, we have to do it from the left-hand side as well. So I'm subtracting 3x from both sides. The left-hand side, 9x minus 3x is equal to 6x. And then, of course, you have your minus 18 is equal to 3x minus 3x. That just disappears. Those cancel out, and you just have the 3 left over. Now, there's multiple ways you could do this. I mean, one fun thing, well, let me just do it the most traditional way. We could add 18 to both sides. 18 to both sides, so that the 18 disappears from the left-hand side. So then you are left with 6x, right? These two guys cancel out, is equal to 3 plus 18, which is 21. Divide both sides by 6. You get x is equal to 21 over 6. Or if you divide the numerator and the denominator by 3, you get 7 over 2. And you are done. Now, I said that there's multiple ways to do this problem. Let me do it another way here in orange. So you have 9 times x minus 2 is equal to 3x plus 3. Well, I see a 9. I see some 3's. What if I just divide both sides of this equation by 3? So if I divide that side by 3, and I divide all of these terms by 3, what do I get? This becomes 3 times x minus 2 is equal to x plus 1. Maybe at this point, if I want, I could distribute this. So this becomes 3x minus 6 is equal to x plus 1. I could subtract x from both sides of this equation. So I get 2x minus 6 is equal to 1. Remember, I subtracted that from both sides, so it disappeared on the right-hand side. I can add 6 to both sides of this equation. I get 2x is equal to 1 plus 6, which is 7. Divide both sides by 2, you get x is equal to 7 over 2. I went through this a little bit faster, but really I just wanted to show you that as long as you do legitimate operations, you're going to get the same answer. And you could verify that this is indeed the correct answer if you like.